This video will describe the command language used with tdbench. Let me start with an overview of what happens when you run tdbench, either .sh for Linux or .bat for Windows. The script's going to look for a help or setup on the command line. It checks to see that Java is installed, checks for first time, and if it's the first time you run it, it will run setup. It will run all of the config files that have been configured. There could be one for each vendor that you set up, and that's used to set up the OS environment variables which are used in the scripts. It then runs the tdbench.jar file under Java, and when that starts up, it opens up the H2 database. The tdbench.tdb is executed one time, and that's a good place to put the class and database alias statements used to define your connection to your databases, as well as the before and after run statements, which are used to provide linkage to the host database reporting. You can also put the zip command in there, which will capture the artifacts left in the temp directory after a test and put it in the logs directory under a file name with the run ID .zip. If there are file names on the command line, each file on the command line will be executed, and then tdbench will exit. If there are no file names in the command line, the user is prompted for commands until they enter exit or quit. When tdbench exits, the script will look for an exception file, and if present, will capture additional diagnostic information about the environment. The syntax rules are fairly simple. Blank lines are ignored. If the line begins with a pound sign, it's a comment. If the line begins with an @ sign, it won't be traced to the console, as otherwise it will be. You can also use the trace off command to suppress the logging of all the statements. Commands are not case sensitive. However, Linux file names are. If you omit the operands for a command, or put a question mark following the command, it will give you the short syntax. For full description of the commands, use help followed by the command name, or followed by the name of a topic. For Q, SQL, or OS commands, if the query or OS command is on the statement, end that with a semicolon. Otherwise, it's going to be taken as a file reference or a search pattern for files. Backslash is an escaping character in Java, and that causes problems in the Windows environment because you need to put a double slash for each slash. Instead, use the /. tdbench will always substitute the correct separator for the environment, and that also makes it much easier to move the scripts between Windows and Linux. Tests start with a define statement and ends with a run statement. The Q statement will take files that are referenced and put them into a queue. The queue is nothing more than a list of the queries or commands that are to be executed. You can have multiple Q statements, and those will be added to the end of the queue. There is also a shuffle command that allows you to shuffle the queries after. The worker statement must be applied for each queue, and you specify the name of the queue, the name from the database alias, and a count of how many workers. If you leave the count off, it will assume one worker. When you click the run statement, queries will be taken out of the queue and passed to the database server for execution. You can also have multiple workers, and all you do is provide a count of how many workers you want to be processing the queries. And you can have multiple queues. Each queue, though, will have a different name and will have a different number of associated workers. After you've put in the queue statement, you can add additional statements to modify the behavior of the queue. For example, you can provide a starting time when that queue is supposed to start. In this case, we want to start the loading 5 minutes into the test. We can put the @ specification on the queue statement, and that's useful for doing query replay. You can paste the arrival of queries using the paste statement. In this case, we want queries from the call center arriving every 5 seconds. We can specify that for the test, a particular queue must finish. In this case, we want the data mining queue to finish. We can also limit how long any one query in a queue is going to execute. In this case, limiting the data mining queries to executing for 15 minutes before they're killed. The parm statement allows you to specify a file that contains parameters for substitution into markers designated by :1, :2, and so forth. You can also put the parm on the queue statement, which will apply that parameter list only to the queries referenced by that queue statement. For high performance queries, you can use the prepare statement, which will reduce the parsing time for the tactical queries and just pass the parameters to the database to use the pre-prepared query. The row count command is useful for your initial serial test to validate that the queries are working correctly by getting the row counts. However, don't use that throughout the benchmark because there's overhead in bringing all the rows back, which causes you to be measuring network and client performance and not the database performance. You can also ask tdbench to display the output from commands on the console. However, I would recommend strongly that you only use one worker and only while you're doing debugging, because it will both harm performance and will be difficult to understand if you have multiple workers writing to the console. You can also request that all the queries in a queue are prefaced with the explain. That's useful for validating that the syntax of the queries is correct and that you've granted all the rights to the objects, and of course that the objects exist. There are a number of options to the run statement. A simple run without any parameters will run all of the queries one time. If there's only one queue and one worker, that's the same as running a serial test. This is a fixed work test. You can also use the serial statement, in which case if your script that you use for all of your other tests have multiple queues defined, each queue will be executed one at a time, only one worker executing each statement, and so that allows you to understand the performance of each query in an idle system. You can put a time specification to specify how long tdbench should be submitting queries, and that can either be in terms of hours, minutes, or seconds, and that's a fixed period submission. When you add the kill option to it, it will loop for 30 minutes executing the queries, and then at the end of the period will kill all the queries that are in flight. You can put the stop statement into a queue, and that will keep it from looping during a fixed period test. You can specify a particular queue to be stopped, or you can specify .me, in which case it will stop the current queue while the other queues continue running for the fixed period. If you put a kill in the queue, like in this case kill all, when that queue finishes running, it will kill all the other queues. Those other queues are probably noise to the queue that you're trying to measure. You can use parameter files with tdbench, which allows you to take one query and turn it into hundreds or thousands using different parts of the database. In this script, we put the parameter specification on the end of the queue statement, and we specify that we want the vertical pipe to be the delimiter. In the query itself, we specify the :1, :2, :3 markers to show where the parameters are to be substituted. And then we have a file with all kinds of different date ranges and state specifications that are supposed to be substituted into the query. Pay attention to how the substitution takes place. It's actually a very simple substitution for the :1. So if you don't have apostrophes in the parameter file, then you must have them in the SQL. If you have the apostrophes in the parameter file, then you don't have them in the SQL. And if it's a numeric, of course, you wouldn't have the parameters in either place. You can use the include statement to reuse code. On the right, we have a list of queries that are supposed to execute at a time that is relative to the start of the test, which were taken from production. On the left, we have two different usages. The first, we are going to run the test substituting the word prod in for :I1. The :I parameters are used for include parameters, and that's to separate them from the parameters used for data, which are without the I. In this case, prod will be substituted in, and we'll have a whole bunch of Q statements executed when we reference it in the prod rerun test. In the prod rerun mix test, we're going to reuse that same list, but in this case, we're also going to add a script that is going to do data loading, and we'll do a run. Both of these are fixed work tests, since all of this only executes one time. You've seen the use of variables. It allows you to build a script once and then use it many different times. For example, we could create a workload test that has parameters for the number of workers and the length of time that it's supposed to run. On an interactive session, then, we could execute that script passing in a 1 in serial, or 5 and 30M. So we're passing the different executions, the number of workers, and the length of time. You could put all the commands into a command file and then execute it in one statement with execute scripts workload all.tdb. tdbench supports any depth of nesting. However, be careful about making your scripts too complex. In an ad hoc environment, you can run these in batch using the invocation of the shell script, with each of the scripts followed by its parameters all enclosed in quotes. SQL and OS statements are executed immediately, and those are useful for setting up the test environment. It doesn't matter where they appear in the script, they are executed as soon as they're found. So for example, they could be ahead of the define statement or ahead of the run statement. Doesn't matter, they'll be executed before the run occurs in either case. The SQL statements that follow the run statement will execute after the run is complete. In this case, we're going to flush all the query logging on the host DBMS, and then we're going to execute a select from our view where the client ID is equal to the :run ID, and we're going to put the results into a file that has the run ID as part of the file name. For more information, go to downloads.teradata.com. There you'll find JDBC drivers and a link to the tdbench for any database page. On that page, you'll find the current release of the tdbench software, the current tdbench user guide, a trifold command reference with all of the commands, instruction videos, and how to get answers to questions, to contribute content, or to report bugs. Thank you.